Airbags. Airbags are credited with reducing numerous injuries and deaths during vehicle accidents. Airbags are built into steering wheels, dashboards, sides of some vehicles, and launch automatically when there is a very fast deceleration, like a crash. They give drivers extra protection, especially during head-on crashes. The reason we have airbags can be explained by the impulse-momentum theorem. The airbag distributes the impact over a large area and for a longer period of time. The more time the force has to act on the passenger to slow them down, the less damage caused to the passenger. Net force times change in time is equal to the change in momentum, which is equal to mass times the change of velocity. To show how this theory can be applied, I am going to hit the wall with my hand, simulating a head hitting a steering wheel during a collision. The force exerted on the hand is high, and at speeds of a car crash could seriously injure somebody or cause death. In the next trial, I am going to hit the balloon on the wall, simulating an airbag in a collision. The impact is completed over a longer period of time, and the force on the hand is less. This less force could be enough to save a life in a car crash. This is a force time graph. These trials will produce a graph much like this one. The area under the graph, in this area, the shaded area, is the impulse. This is an example. A 75-kilogram man is involved in a car accident. He was initially traveling at 65 kilometers an hour when he hit a large truck. If he had no airbag in his car and he came to a rest against the steering wheel in 0.05 seconds, determine how much force was exerted on his body. B. If he did have an airbag that inflated and deflated correctly, bringing him to rest over a time of 0.78 seconds, determine how much force was exerted on his body. Answer for A. First change 65 kilometers an hour into 18 meters per second. You can calculate the change in velocity by getting the final velocity minus the initial velocity, which is equal to negative 18 meters per second. Force times the change in time is equal to mass times change in velocity, which means the force is equal to mass times change in velocity divided by change in time. This can be calculated to come out to negative 2.7 times 10 to the power of 4 newtons. This is the force exerted on the body. For B, force times change in time is equal to mass times change in velocity. This is the same calculation, but instead of using 0.05 seconds, 0.78 seconds is subbed in, which calculates a force exerted on his body to be negative 1.7 times 10 to the power of 3 newtons. This is only about 6% of the force without the airbag. This is a big difference, which is enough to maybe save somebody's life.